When it comes to looking at lubricants that we put in an engine, there's a lot of different properties that we could look at and a lot of differences between different manufacturers and different types of oil. But I want to focus in on some of the key differences, the key properties that you should always pay attention to when you're looking at lubricating oils for an engine. And here's the list that we're going to look at. We're going to look at the viscosity of the fuel. We're going to talk of the oil. We're going to talk about its thermal resistance. So viscosity is how thick the fluid is, how thick the oil is, and the thermal resistance is, does it change when it gets hot, and how does it change? So those are going to be key things that we're going to look at. We're going to look at the longevity of that oil. So does that viscosity or other properties break down and change over the life of the oil and so forth? We're going to talk a little bit about the foaming. So again, I mentioned that earlier, that if those components are spinning inside that engine and that oil's in there, if it's splashing around and getting bubbles trapped in it, those bubbles can get into pumps and components and cause a lot of damage. So our oils have got to be able to have some anti-foaming capabilities, and they've got to have some cleaning capabilities. And these last two, and I could probably list a whole bunch more things down here. These are all things that are commonly taken care of with additives. So different types of additives that we put into our fuels or into our lubricating oils. So our lubricating oils are going to have detergents in them. They're going to have some cleaning agents that are going to prevent varnish type buildup and other types of buildup, and be able to keep those engine components clean and keep those particles in the oil. Well, because of that, because of the cleaning and some of that functions of our lubricating oil, and because of the viscosity, we have to change the oil periodically. It doesn't last forever in an engine. And the decision to change the oil is dictated by the manufacturer. They typically give you the change intervals, so how many miles on a vehicle, how many hours on a small engine or something like that. They tell you how often you have to do that. And that's dictated generally by two things that are happening there. One of them is the viscosity and thermal resistance and longevity. Is that fuel breaking down or that oil breaking down over its life? Is its viscosity changing? Is it other properties of that oil changing just because it's getting old, it's been heated up, it's been rubbed, and it's just getting tired? So its properties will break down. So that's one of the reasons that we have to change oil. The other reason is all the dirt and everything that's built up in there. So those are the two things that will dictate how often and when we have to change our lubricating oil. And conditions will sometimes change. So sometimes the manufacturers will say, if it's in a clean environment and so forth, this is one service interval. If you work in really dirty, really hot environments, that service interval should be a little closer. You should change that oil a little bit more often. So those are things that you need to pay attention to while maintaining the engine, and how often I need to change those lubricants. So let's look a little bit more detail now about the viscosity. So what is the viscosity? I think we have a general idea of viscosity is how thick the oil is. And we can measure that a lot of different ways. There's a lot of instruments out there that can do that. The traditional way is these glass tubes with bubbles on it, and we put the oil in and look at how fast the oil moves through those tubes, moves through a small capillary within that tube. We actually have more sophisticated electronic instruments where we can put the liquid in a container, and we have something that spins inside that container, and we look at the resistance to the stirring, and that resistance will tell us something about the viscosity of that fluid. The way it was traditionally measured and kind of the standard for oils is that we take a can or a bucket and we put a hole in the bottom of it and see how long it takes for the stuff to run out the hole. So if that's a standard size hole, a pretty tightly controlled hole, and we put a really thick material in there, it's going to take longer for that material to run through that hole than it would take a very thin material to run through that hole. And so that's where our ratings actually come from. So that's kind of the source or the idea. Again, it's more sophisticated than just poking a hole in the bottom of a can, but it's that same general idea. It's a very controlled hole, very controlled size can, and so forth. And how long does it take that material to run out through that hole? And so we have these ratings then that are a numerical rating that a lot of us are very familiar with. So we have these SAE numbers, and down here is a little chart that's specifications for a certain engine that I pulled out and said this is what they recommend for that certain engine. And we have numbers in there. We have this SAE number, and I'll talk about what SAE is in just a minute. But an SAE 30 or 5W30 or 10W30 or something like that, 5W20, so different types of oils. Those numbers, that rating is that amount of time that it takes to fall through that hole. So that number, a larger number, means longer time, means a thicker oil. Typically, our engine oils are about from the range of about a 5 on that rating scale to about a 50. So that's typically where you see. So 10W30s, 5W20, just SAE 30. So those different numbers. So that's what those numbers come from. That's the rating. Again, higher number takes it longer to run through the hole. That's a thicker oil. So more viscous, okay? Thicker oil. So that's what you remember on that. Now, we do have this thing called a multi-viscosity oil, and a lot of our oils are this. And so an oil might be a single viscosity, so as in you see in the chart down here, we have a SAE 30. So that's just a number 30. That's going to have a viscosity of 30, whatever that corresponds to, or that thickness of lubricating oil, no matter what the conditions are, within a reasonable range of conditions. But we have these multi-viscosity oils. So a common one, again, is like a 10W30. So that's the rating that you'll see on that oil. So those two numbers are two different viscosities, and they happen at two different temperatures. So when I see the W on a rating, on a viscosity rating for motor oils, that is a winter rating. It stands for W, stands for winter. But what this means is that they've tested this oil, and at 0, this number with the W in front of it was tested at 0 degrees Fahrenheit. So that means that whatever the time was that it took to run through that, we put that oil at 0 degrees Fahrenheit, so made it really, really cold, and put it in there and see how long it takes to run through that. Then the numbers without the W are generally taken at 212 degrees Fahrenheit, which that's boiling point of water. So we take it up to really hot, or hot enough to boil water, and then we do the test again and see how that runs through. So what this does, it gives me an idea of what this oil will act like in the engine if I have to start it on a really cold winter morning. It's going to look like a 10W, a number 10 viscosity. So relatively thin. Lower number is a relatively thin oil. But when I heat it up, when it gets hot, when it starts running in that engine, it's going to run at a higher viscosity. So it's kind of backwards from what we think happens. And we saw that with cooking oil, different things that we've played with in the engines there, that the hotter they get, the thinner they get. But these motor oils with multi-viscosity have polymers in them. Polymers, they're basically, different types of chemical compounds that they put in these engines so that when they heat up, they actually get a little bit thicker. And that's really what we want. So when I start that engine, I don't want that oil to be so thick that the engine can't turn and the lubricant can't move through the engine and it doesn't work right and it just is really hard to start and really hard to manage. I'd like that oil to be a lot thinner so that that engine can spin easily and get started. But then I don't want it to stay that way very long because it's not going to lubricate as well. So I would like it to get thicker as that engine heats up. And so that's what this stuff does. It's going to heat up to more like a 30 weight oil when it's running hot. So I get more viscosity, more lubrication. It's just a better oil then to protect the engine. So that's what our multi-viscosity oils are. So again, you look at your engine, look at the manufacturer recommendation, and they'll often tell you for different temperature ranges. And so this chart here is for different temperature ranges. When it's warm temperatures above 40 degrees, they say SAE 30, that's a good oil to use, and that's pretty common oil to use in smaller engines. Now, if I'm going down to lower temperatures, down to like 0 Fahrenheit, they're suggesting a 5W30 or 10W30. So I want that thinner oil so that this thing is going to start a little bit better. It's not going to be real thick and sludgy and just hard to get going. Now, if they say you go really, really cold, then they're suggesting some synthetic compounds and so forth that are going to be a little bit better even at those much colder temperatures down there. So again, the manufacturers will recommend different oils for different temperature ranges, and so that's what you need to pay attention there to on the viscosity to understand what those oils are going to do. Now, let's go a little bit more detail in those specifications. So I mentioned that SAE number, SAE 30. Well, SAE stands for, and this is a good thing to remember, this is the Society of Automotive Engineers, SAE. And they have developed standards that dictate the viscosity. So they're the ones that came up with the procedure or that idea of poking a hole in the bottom of a can and measuring how the time it takes for it to run out through that hole to be able to get that number. So they've developed these numbers. It's a common number that's easy for us to put on oil containers and so forth to be able to indicate what kind of oil that we're getting. So the Society of Automotive Engineers does that. But that's just the viscosity. There's a lot more going on in those oils. And even as engine technology progresses, the demands for what we expect lubricating oil to do continues to increase. And so the demands on oil manufacturers have gone up. So they have to adjust what kind of properties they're building into their lubricating oils, what kind of additives they're putting in the oils so that they can perform and do the things that the modern engines need them to do. And so there's another organization called the American Petroleum Institute, and they do a lot of things, but one of the things that they do is have ratings for oil that go beyond just the viscosity. They tell us more about, again, some of that detergent properties of the oil, some of the corrosion resistant properties of the oil, and other things. So there's just a lot that's built into that. And so they have come up with some additional ratings. These are the things that people often ignore. When we go to the store to buy oil, we look at that viscosity number that's stamped right on the front of that can, and we say, oh, that's what I need, let's run with it. Well, there's more that you should be looking at, that we should be watching for, particularly with compression ignition engines. So I have a list down here with spark ignition engines. The American Petroleum Institute, API, they have ratings both for spark ignition engines and for compression ignition engines. So they're separate oils. So there are specific oils that are designed specifically for gasoline engines and specifically for compression ignition engines, for diesel engines. So the spark ignition engines, they have an S in front of that rating, so it's going to be S with another letter. And they're the letters of the alphabet, and they keep progressing as there's more and more standards, more and more rigorous requirements of that oil. They keep adding letters, or they keep going up in the alphabet. So a number of years ago, the oil that was being produced was an SG. Well, then manufacturers said, we need a little bit more, we need this, we need that in the oil. So the manufacturer said, okay, we can put that in. Then the American Petroleum Institute said, okay, we'll call that an SH. So if it meets all those requirements, that'll be an SH. Well, then there's more requirements. Okay, so then that'll be an SJ or an SL or an SM, okay? And we skip some of the letters in here, so there's no I because I get mixed up with an L, you know. There's no K in there, stuff like that. But basically GH, J, K, no K, but L, M, N. We're up to P. We skip O because it looks like a 0. So we're up to new oils coming out this year will meet an SP requirement. So more demands, more requirements, more things that those oils have to do. Now, the nice thing about these oils is that if you have an SP, it supersedes everything else. What that means is my engine is going to be specified for a certain level of requirement of properties. Again, it's a lot of different properties that are built into this. So maybe I have an engine that was manufactured a few years ago, and it says it requires an SL type oil. Well, I go to the store and I look at my oil and it's an SP. Well, that's fine because P is SL plus. So it supersedes this. It does everything that the SL needs plus more. Okay, so now if I've got a brand new engine and I happen to find a case of oil laying in the back of my shed somewhere, and that brand new engine is needing an SN specification for oil, and that oil that I pulled out of the shed was an SJ, I should not use it, because there's something that that oil does not do that N engine is going to require. Okay, so that's kind of critical. That's something you want to see. Again, it's not a big deal if you're buying brand new oil, because most of the oil is going to have the higher letter and it supersedes everything else. Now, that is not necessarily the case with compression ignition oils. Compression ignition oils are not necessarily superseded by the new oils, don't necessarily supersede the old requirements. So there's a lot of requirement changes that are different. And so you're going to have things like a C, and again, there's going to be a C in front of it. There's going to be a letter and a number. The number generally indicates the tier, and we talked briefly about the tier emissions in our engines, a tier 1, 2, 3, or 4 emissions control. So this 4 is geared toward the tier 4 emissions requirements. But there's also the letters on front of it, an I, J, K, whatever. Okay, so CJ-4, a CK-4, C being compression ignition, 4 being tier 4. The K then is the letters. Now, a K does not necessarily supersede a J. They are different. And a J doesn't necessarily supersede an I. They could be different. So this is one of the things where you have to look at your engine and say, what does the manufacturer require from that engine? And is that oil going to meet those requirements? Now, how do we know when I go pick up a jug of oil, how do I know what it is? Well, there's marks on that oil that indicate all this for me. So here's a couple examples. This is a typical oil for a compression ignition engine. And you can see here that it actually says in small letters right in here, meets API service CI-4, GC, there's a CK-4, a CG-4, so it lists all of those service requirements, all those different service levels, and it lists which ones that it meets, and so it meets a bunch of them. Okay. The other thing that you'll find on these oils is a little round seal like this that tells me what's going on. It gives me that same information in there. This is actually the standard seal that you're going to see. A lot of manufacturers will put this list up on there just to kind of make it, make sure that you've got it a couple different places that can see it. So this is a compression ignition oil. This is a spark ignition oil, so for gasoline engines. Again, the same kind of a circle down here with that information, and it tells me what it is. And again, this one says meets or exceeds requirements of the API SN, so American Petroleum Institute SN requirements. So it tells you what it meets. Let's look at those symbols a little bit closer. Let's blow them up so we can actually see them here. So again, sometimes you'll see this symbol on an oil that says, hey, this one's for gasoline engines. So you probably should not be using that in compression ignition engines. But this is some examples of what that circle is going to look like. Okay, what that mark, that API certification mark, is going to look like. So for gasoline engine, you're going to have this S up here for the spark ignition engine, and this is an SN. So if I had an engine that needed P, N is not going to cut it. I need to make sure I've got one that says SP on it. Okay, if I had an engine that needed SJ, well, J is way below N in the alphabet, so yeah, N is going to be fine. That's going to work pretty good for me, okay? And there's some other standards out there. GF is a different rating, a different standard certification that oil will also meet. So that tells me that. In the center, it gives me the viscosity. So this is an SAE 5W30. So those are the numbers that we recognize. And down at the bottom, it may have some extra things that it gives us. So it might give us some resource conservation, some energy enhancements, and things like that oil gives for us. These are also things that you have to pay attention to. Particularly, an example is motorcycles. So a lot of motorcycles, they have the clutch in the motorcycle is actually in the crankcase. So the transmission and the crankcase and everything is all one. So when that oil goes in there, it's lubricating the engine. It's also lubricating the transmission. That clutch is also in that oil as well. So it's a wet clutch that operates in oil. Well, if I've got some extra additives in here that are supposed to be for extra energy conservation and super kind of whatever lubricating capacities, that might damage that clutch. It might make that clutch slip. So I might want to make sure that some of my oils don't have some of those things in. Again, this is things you got to look at, the manufacturer's recommendations, what they tell you on that. Okay, so that's a gasoline engine. Again, it's the diesel engine, compression ignition engines. API service number up here, this that CJ, CIJ. If I needed a K, this wouldn't do it. So this is only going to be the J and the I kind of specification. So that's what you got to watch. And again, some of the energy enhancement stuff that you have on the bottom of the circle down there. So that's the thing that we've got to do. We've got to understand how to read those circles, how to find that information. So that's a lot. And again, we can spend a lot of time looking into all this stuff. So what is it that I need to know from this? Let me summarize all this. Make sure you understand what the lubricants are doing. All right, some of the details of why we have friction, what's going on in there, what's causing that friction. So how those lubricants work, how they get into those components physically. So, is it a splash system? Is it a pump system? Thinking about clearances on my journals and stuff like that to make sure that that clearance matches with the viscosity of the oil so it can get into those spaces that it needs to get into to be able to lubricate that engine. Make sure you understand the key properties of the oil that we've got to think about, the viscosity, longevity, some of those kind of things. Make sure you can ask about that. And understand where to find these specifications and certifications. So understand the specification of viscosity and understand some of these ratings, that are additional beyond viscosity. Some of the extra additives and different things that oil is supposed to do, and the fact that as those standards change, as there's more demand from engine manufacturers, the oil manufacturers are doing more with their oils, with the compounds within the oils, and changing those compounds. And so oils that you buy today are different than oils that you bought just a couple years ago. And be careful about what engines that you put that stuff in, because that can have an impact on what's appropriate for a certain engine. So that's a summary. That's lubricants. There's a lot more to it than just getting the right viscosity and putting in the engine. So make sure you understand all that.